Write a line of fit. Use interpolation or extrapolation. Remember, interpolation is when you predict the data within the range that's given, and extrapolation is where you make a prediction outside of the range of data. And in this example, number 251, if we go ahead and take a look at it here, we can see that this is it. This is the graph that we have. It's the consumption of milk in gallons. We have consumption in gallons as our y-axis, our dependent variable, and the years since 2000 on the x-axis are independent variable. So this point here on the x-axis represents 2000, 2001, 2, 3, 4, and 5. And then here are the number of gallons, I assume per year, right? So that's the data. And we are going to use these 2 points, which are on that chart that we just looked at, where our x is 2002, and the number of gallons in 2002 were 21.75. And another data point is 2004, and the number of gallons then was 21. So we need to write the slope-intercept form of an equation for the line of fit using these 2 points. And you can see in the chart, if we did use those 2 lines, that's this one here and that one there, it would create a line of fit that would approximately go through most of the data points, right? Alright, so slope-intercept form, that is y is equal to mx plus b. And so in order to write it in slope-intercept form given 2 points, we first need to find the slope. So m is equal to the difference in y's over the difference in x. And the first point is going to be our x1, y1. Then we have x2, y2. And remember, the equation for slope is y2 minus y1 over x2 minus x1. And if we plug in our data, what we're going to get is 21 minus 21.75 over 4 minus 2. And if we do the calculations, we'll get m, the slope, is equal to negative 1.75 over 2. And if we drop that into a calculator, divided by 2, I'm sorry, it's actually not negative 1.75, it's negative 0.75. Right. So if we drop that into a calculator, we will get our slope is negative 0.375. 0.375. Alright, so now that we have our slope is 0.375, we can go ahead and plug into our slope-intercept form of the equation. And we can say y is equal to negative 0.375x plus b. And now we want to find b, and we can use either this point or that point as our x and y values and solve for b. So since this point here, x2, y2, has whole numbers, I'm going to use that one. So I'm going to plug in 21 for y and 4 for x and solve for b. 21 is equal to negative 0.375 times 4, which is our x, plus b. I'll do this calculation here, and I'll get 0.375 times 4 is equal to 1.5. I'll continue writing my equation up here. 21 is equal to negative 1.5 plus b. And now we want to isolate b, and we can do that by adding 1.5 to both sides of the equal sign. And we will get 22.5 is equal to b. So we have our m and we have our b. So to write the equation in in slope-intercept form, we'll plug in our m and plug in our b, and we'll get y is equal to negative 0.375x plus 22.5. I'll put a box around that. Now we're asked to predict the milk consumption in 2020. Is this interpolation or is this extrapolation? Now, how can we predict the milk consumption in 2020? Well, going back to our chart here, we can see that the years are the x-axis, and 2020 would be 20 on the x-axis, since we start at the origin at 2000. So 0 represents 2000, 1 represents 2001, and so on. And so 2020 would be 20 on the x-axis. So predict the milk consumption in 2020. So we're going to say x is equal to 20. Right. And what is milk consumption? That is our y in our equation here. Milk consumption is equal to this rate of change times the year plus 22.5. So in order to calculate how much milk, or y, we will substitute in 20 for x in our equation. Let's do that now. Y is equal to negative 0.375, and instead of x, we're going to put 20, and we're going to add 22.5 as our b. So let's go ahead and make that calculation. Y is equal to 0.375 times 20 is equal to negative 7.5 plus 22.5. So our y is going to be equal to 15. And 15 what? Right. Well, looking at our chart here, our y is in units of gallons, right? So our answer is going to be y is equal to 15 gallons. Now for C, we need to predict in which year milk consumption will be 10 gallons. Well, we talked about this earlier, that y is the amount of milk consumption in gallons. And they want us to predict what year the milk consumption will be, and our year is our x. Y is our gallons. So in order to solve this problem, we could set our y equal to 10, and we can solve for x. This is the equation that we have. And we'll go ahead and do the calculation. So let's solve for x by subtracting 22.5 from both sides of the equal sign. And on this side, we will get negative 12.5 is equal to negative 0.375x. Now to solve for x, we'll divide by the coefficient, divide by the number in front of the x. So let's do that now. So let's go ahead and make this calculation. We have a negative divided by negative, which is going to be positive. And we'll do 12.5 divided by point. It's 33. Positive 33.3333 is equal to x. And so we can go ahead and simplify this, and we can say that milk consumption will be 10 gallons when the year is 2033. 2033. And I'll put a box around that. Now our final question is it reasonable to use the equation to estimate the consumption of milk for any year? Explain. Well, if we're looking at this chart here, we can see that there is a trend as every year moves on, and the rate is staying the same. Right? There's a more or less constant rate of change between any 2 points. So we can say that yes, if the current trends continue, the consumption of milk will continue to decrease.